Now that we've defined radicals and roots, we can start talking about exponents that are fractions. In fact, if I want to refer to the nth root of a, it's the same thing as a to the 1 over n. On the other hand, the nth root of a to the m power is the same thing as the nth root of a, all raised to the m power, which is a to the m over n. So the top of the fraction tells me what power I should be raising it to, while the bottom tells me which root I should be taking. For some examples, I have 9 to the 1/2 power. A 1/2 power means I should be taking a square root, so I have the square root of 9, which is 3. Something like 27 to the 2/3 power. The 3 on the bottom of the fraction means I should take a cube root, and the 2 on the top means I should square. So I have the cube root of 27 squared. The cube root of 27 is 3, and then I need to square it to get 9. For something like 8 to the negative 1/3, we remember that fractional exponents mean move it to the bottom of the fraction, so this is the same as 1 over 8 to the 1/3. And a 1/3 power means a cube root, so I have 1 over the cube root of 8. Since the cube root of 8 is 2, I get the answer of 1/2. With rational exponents, all of the properties that we previously looked at still hold. So I can still use properties to simplify things. Multiplying two things means add the exponents. So I have x to the 2/5 plus 7/5, which would give me x to the 9/5. In something like this, I'm going to start with the top of the fraction. Since I'm multiplying across the top, I need to add the exponents. That gives me 7 to the 1/3 plus 7/3, which would be x to the 8/3. Division means I need to subtract exponents. So I have x to the 8/3 minus 4/3, which would give me x to the 4/3.